Hello there, furries, ferns, and furnaces. It is I, Rubik's the Slime, and as my name would imply, and my former name would especially imply, I happen to be a bit into solving cubes, yet somehow this is my first video relating to that. But what we're going to learn today is a very useful technique. It's totally useful. If you've never solved a cube before, that's okay. I'm not going to teach you how to solve a cube, but I am going to teach you about part of it. You see, a lot of methods end with the last layer, like this. You have all of this solved, and now you just gotta solve the last layer. And there's a few ways you can do this, but generally the best way is to first orient all of the pieces so that the top face is one single color, and then permute the pieces so that they're actually in the right positions. We're going to specifically look at that first part, which is generally called OLL, which stands for orientation of the last layer. Now, there's a few ways you could do this as well. The fastest way is called one-look OLL, where you just solve this part in just one step every single time. And to do that, you only have to learn 57 different sequences of moves, also known as algs. Now, if that's too much for you to remember, then that's totally reasonable. That's why we have two-look OLL, where you do it in two parts. First, you do the edges, you get those all fixed up, and then you do the corners. And this is a nice compromise, because you only need to learn a total of 10 algs instead of 57. But maybe, just maybe, even that is too much for you. That's where a very common beginner method that you might call 2-alg OLL comes in, where you have to do it in a few steps, but you only have to know 2 algs. The first is called f-sexy f', though you may have to do it multiple times. And then the other one is soon, which, I mean, it goes like this. Very easy to remember. And to use it, very simple. If you have 2 or 4 wrong corners, then you just make sure that this spot right here is yellow, and then do soon. And then if you have 3 wrong corners, exactly 3, then you just make sure that this spot is yellow instead of this spot, and then you do soon. And then maybe you have to do it again, but eventually, say, orients all the pieces, and you only need 2 algs. But what if we could do even better? What if we could do the entirety of orientation of the last layer in just one algorithm? This is 1-alg OLL. Let's start by learning how to do it, and then we'll go over how it works, because it is kind of interesting. And then we'll go over the pros and cons of it. Now, let's start off with the algorithms that you'll need to know, or rather, singular algorithm, kind of the whole point. It goes like this. Wide R, wide F, U2. Yeah, that's right. Not only is there only one singular algorithm, but it's only 3 moves long. Now, to actually use this thing, just like with 2 algs, you're going to need to recognize some seemingly arbitrary patterns. The first one is, I don't really have a good name for it, just the reverse comma, I guess. We need these 2 stickers to be yellow at the same time, and to do that, you're going to do the algorithm until that happens. So, nope, 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 nope. There we go. Now that we have that, we're going to rotate it counterclockwise, and now we need a different shape. This time, we need a Y shape. These 4 stickers right here all need to be yellow at the same time, and if you need to think of that as a different shape in order to remember that, then I suggest you do that. But in order to do that, you just do the algorithm until it happens. So, nope, 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 nope. Yep. Now that we have the Y shape, or whatever other shape you managed to come up with, now we're going to rotate it counterclockwise and go for yet another shape. This time, this 2x2 square right here. And to do that, you're just going to do the algorithm until it happens. So, nope, 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 nope. Yep. Now while you do that, this Y shape is probably going to disappear. Don't worry about it, it happens. time to move on. I think you probably know what to do by now. We're going to rotate it counterclockwise and then perform the algorithm until a certain thing happens. And this time, that certain thing that we need to happen is super easy because, well, it's just the entire top face being all one color. So, nope, 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 yep. There we go. Now all you gotta do is PLL and then you're done solving the cube. Now before we move on, let's make sure that it's down for everyone by briefly going over it for all of the lefties out there. So for the algorithm, instead of what we did before, it's going to be wide L prime, wide F prime, U2. Yeah, super easy. In fact, it's so easy I think I can actually do it a bit faster. Which is strange because, like, I'm definitely right-handed. I mean, sure, I always do one-handed solving using my left hand, but like a lot of people do that simply because, you know, it's easier for recognition. Except that I'm really good at flipping things in my head, and like I've literally tried to get good at doing it with my right hand, and I just can't seem to turn it quite as easily. Excuse me for 1 minute. And this is the part in writing the video where I suddenly started to realize a lot of things that really started to question whether I actually am right-handed, which only starting to realize this at 28 years old, after previously quitting speedcubing altogether because I was convinced that I did not have the dexterity to achieve my goals, and also being 4 months into feminizing HRT, yeah, it was a very emotional several hours. Anyways, let's do this. Okay, so first thing, you're gonna need these two spots to be yellow, and hey, we're already done. But now you're going to rotate it clockwise, and now do it until it, you get the Y shape. See, right there. Now you rotate it clockwise again. Now you go for this square right here. And, well, already there. Now rotate it one more time, and now you go for the finish. See? Just like that. Now, let's go ahead and briefly talk about how this thing works. First of all, if you know your stuff about cubing, then maybe you may have noticed that this is not truly the full algorithm. You actually have to do it 3 times. But because we're just repeating the same thing over and over, you don't really have to know that you have to do it as a multiple of 3 times. But you'll notice that what it does is it rotates the corners and flips the edges, but it does not move them around. And so here's the really nice thing about this. Because the edges cycle every 2 executions and the corners cycle every 3 executions, that means you're going to go through every single combination. Or rather, you pick any pair of corner and edge, and that pair will go through every single combination. However, in order for it to truly work, for the final step, you need to go into it with all 3 of these corners being oriented the same way, because they always turn together. So, that's where the Y step comes in. Because, well, the Y step is right here. It makes sure that these 2 corners are the same. Which, when you have this one being correct and these 2 are the same, this one will also be the same as these 2. So technically, when going for the Y shape, you technically only need them to be oriented the same way, but anyone who would find this method to be even remotely useful would not understand that concept. So we go for the Y shape. And for the Y shape, well, we start by getting these parts. Doing it here, we'll rotate these ones. So we get, well, really just this one, correct? And then rotate it. And now we're rotating these parts right here, which means we pick that pair of corner and edge, and that pair will cycle through every possible combination, which means that this one's correct, and these 2 will be correct eventually. Rotate it again, and now we're affecting these parts right here, which that edge is already correct. We only need these 2 pieces, a corner and an edge, and so those go through every combination. And then finally, the final step, which we set up to make sure that these two would be the same, and therefore this would also be the same, and then just finishing that will finish the entire thing. Now, one other little detail about this is that due to the fact that it doesn't move the pieces around, you can also use this to do OLL after PLL. Personally, I do not recommend doing that because it is very difficult to recognize what is going on for the permutation part. So yeah, don't do that. Anyways, now let's talk about the pros and cons. First of all, pros. Great for beginners in the sense that there's only one algorithm. Okay, now for the cons. First of all, there's wide turns, which beginners don't do well with wide turns because they have a tendency to look around the cube, except not by this, they do it by re-grabbing the cube so that they have no idea where they were, and I swear sometimes they do it like in the middle of an algorithm. So wide turns, bad idea for beginners. There's also the part of, you have to remember all the different shapes, but when you really think about it, it's actually not that more to remember compared to doing it with two algs. But then there's the obvious thing, which is how long it takes. You could try to go for certain optimizations, like when you just reach it and you're in this position, you could go, well, I need this spot to be yellow, but instead of doing that, I could just go with this spot instead. And that would work. And you can actually do that for both the first step and for the Y step, though you can only really do it for the square shape if you really know what you're doing, which you probably don't if you're using this method. But even if you try to optimize things, it's still going to be just ridiculously slow, so there's almost not even a point in even trying. Worst case scenario I could find was this, which is eerily close to the one that we did on the first example, just rotated once counterclockwise. Yeah, this situation you gotta do it 45 times. Which is a lot more than the up to like 6 executions that you would have to do for 2-alg OLL. A lot more. So it is just dramatically slower than basically any other option. Horrible idea. Don't actually do this. Maybe it could make its way into an actual beginner method at some point. I don't know. But I think it's mostly just good for theoretical purposes. Of course, with 1-alg OLL, you might be thinking, well, I wonder if it's possible to do 1-alg PLL, the permutation of the last layer, the second step of the last layer. No, because in order for it to work, you would need to have a PLL. You can do an adjacent swap on both corners and edges at the same time, which immediately narrows it down to just G, J, and R, and after a little bit of experimentation, yeah, none of them work. Anyways, if you enjoy cursed solving methods, then stay tuned because everything I do is at least mildly cursed, and also I'm planning to do a video about my signature PLL method called GPLL, where you utilize the fact that almost every PLL case can be turned into a G-perm using a G-perm. Anyways, thanks for watching, and as always, trans rights are human rights. Don't look at it as the flag being too big, look at it as the table being 600% gay.